Science Foundation to the Department of Defense. So it turns out, this is the NREL world record efficiency chart for the past 30, 40 years. It turns out the Department of Energy has funded more than half of these world records. The US owns more than half of these world records over the past 30, 40 years, okay? So we have a great impact in terms of leading the world in invention and innovation. Okay, let me talk a little bit about transitioning that through the first value of death. Dr. Sakar leads the team that runs the SunShot Incubator program. This is a very exciting program that helps small businesses transition to first value of death. So I mentioned before, we have great research universities. Okay, we have great ideas from our national labs. We push the envelope really hard in terms of technology innovation there. But getting that innovation to the marketplace has lots of different hurdles. One of the first hurdles is to demonstrate that little tiny laboratory idea, okay, maybe even a laboratory proof of concept, into something that looks like a real product. And traditionally in this country, that's initially financed with venture capital, or in this case here, with the support of the incubator program run at the Department of Energy to help bridge this first valley of death. So since 2007, the Department of Energy has run this program about 7 times. Okay, this is a really exciting program. About 40 or so companies have graduated from this program. These are small businesses, startup companies, but some of them you might be hearing of them either today or soon. Some of these companies have already shut down. Remember, this is a risky enterprise. These are startup companies. Some of them will fail. Okay, if you don't have companies that fail, that means you're not taking a risk. And so, but some of these companies have been very successful. For example, Novolite was acquired by DuPont about a year ago. Some of these companies like Alta Devices, I'll show in a second, have done some amazing things in the PV space. So since 2007, this first round, the first round of companies, about 7 or 8 companies, the U.S. taxpayer has invested a small amount of money, about $17 million or so initially. What's really exciting about it is that after this initial $17 million investment, those companies have been able to raise follow-on private capital of close to $2 billion. Okay, initial technology at the very small scale, getting some help from the taxpayer, have been able to be leveraged with tremendous resources from the private sector. And they're building factories, they're trying to grow and create jobs. So one such company that's very exciting right now is Alta Devices. They've actually been breaking world records for the past couple of years in terms of the performance of a thin film solar cell. 29% in a flexible configuration, 29% efficiency. That means almost a third of the energy that's coming from the sun is being converted to electricity. This is really cool. However, as great as we are as a country in terms of innovation at the research labs and also innovation in terms of small businesses, where we fall behind and are falling behind very dramatically is the transition of innovation to manufacturing. You look at 1997, the US held a 42% worldwide market share for the manufacture of PV cells and modules. 42%. That's world leading. We own the world in terms of manufacturing of this technology. And rightly so. The modern silicon solar cell was actually invented at Bell Labs in the 1950s. So we invented this technology here, we developed it, we made it better and better. By 1997, we were the world leader in the manufacturing. The world market was fairly small, fairly niche applications. The costs were still pretty high, but we owned the world market. Over the past 15 years, it's actually not that long of a time period. I mean, I certainly remember this time period. 15 years, our market share has eroded to less than 4% last year. By the end of this year, it'll be less than 3%. Think back, many of you are in the semiconductor industry. Think back in the 80s, mid-80s. Very similar situation. And Dr. Wesner will be speaking about some of these trends and some of these lessons learned from past experience about losing market share and how do we regain that over time? How do we recover this? And so one of our first forays into trying to do this is actually thinking that investing in innovation at the early stages is not enough. We actually have to innovate in our manufacturing lines as well. We have to innovate in order to reduce costs at scale. so the PV Manufacturing Initiative is a concept to create consortia around the country to work on manufacturing challenges that will enable our manufacturers, our domestic manufacturers, to compete on a global marketplace. Okay, and so we built 3 of these centers. One is right here in Albany at CNSE and Semitech, borrowing on some of the experience of Semitech for the IC industry, as well as an earlier stage consortium at Stanford University and Berkeley, and the Silicon Valley Technology Center, a manufacturing development facility. So here too, I also borrow from the IC industry because we're here on the grounds of CNSE. Andy Grove, co-founder and former CEO of Intel, very astutely proclaimed that if we abandon today's commodity manufacturing, this can lock us out of tomorrow's innovation economy. Because after all, the solar industry is actually an offshoot of the semiconductor industry. For the longest time, the silicon solar industry got its leftovers, got the leftover silicon from the IC industry. All the quote dregs of the silicon manufacturing processes were being used for the solar industry. And so imagine where we would be if we didn't have the IC industry in the United States. Now imagine what would be 20, 30 years from now if we don't have a solar industry in the United States. What technologies are we missing out on in the future if we don't make things here? Because after all, the innovation ecosystem is grounded on manufacturing. When you manufacture in a region, you create an innovation economy, an innovation ecosystem around that region. You create supply chains, you develop new technologies. People who work in factories are actually very, very smart. They innovate. They'll spin off new companies. They'll work on new ideas and they'll improve processes. Climbing up that performance curve takes hard work in our manufacturing lines. Other countries realize this. To compete in the global clean energy race, we have to do more than just invent. We as a country do a great job inventing. Okay, we have to do more than just invent technologies. We have to make them. Okay, we have to sell them and use them too globally. And so last year we started to realize this, and Dr. Sakar ran a program, or is running a program called SunPath, Scaling Up Nascent PV at Home. Very US manufacturing centric. We just made awards to 3 different companies, one of which I'm highlighting right here. It's a company called Soitec, another company with roots in the IC industry, and I believe a member of Semitech. They're building a 200 megawatt factory down in the San Diego area. They already have offtake agreements for hundreds of megawatts of the product because they're deploying with their partners large CPV farms out in the San Diego area. This is very exciting. It's going to create thousands of jobs and leverage tremendous resources from the private market. $25 million in US taxpayer resources is leveraging about 3 to 4 times that from the private markets. And as Pradeep mentioned earlier, even if you paid nothing for the hardware, you'd still pay thousands of dollars for a residential PV system. As the hardware cost, as the module costs have come down so dramatically in just the past year and a half, 2 years, what we find is the soft costs, the non-hardware costs, have not moved much at all. And this is the challenge that this community here is hopefully will tackle. One of the issues here is actually still related to hardware. It's actually, can you use technology to validate the performance of PV to reduce the financing cost? Because there's certainly a lot of uncertainty associated with new technologies.
Try to take a loan out for $1 billion to build a utility scale plant. If you can increase the confidence in the future energy production of that plant by a fraction of a percent, you can bring down your financing costs. So regional test facilities allow us to take technology developed in the lab and scale it up to a demonstration scale.
So if you have a new product and you put it out in, say, in the desert, but that product turns out to be sensitive to humidity and corrosion, you may get a very good result in the one location, but find out later that the product has a problem in another.
again, what we're doing here is actually setting up regional testing facilities in various climates around the country. We call these the RTCs, and there's two main ones. One based near NREL, and the other based in Colorado, and the other based in New Mexico to test PV modules, and also one in Florida, to test PV modules at large scale in order to validate their performance, and that this will help help companies assure their financiers that their products will last and perform as expected and reduce financing costs. But why are the rest of the soft costs so pricey? Well, it turns out it's a fairly confusing process. And the process to install solar on your rooftop, depending on where you live, be it New York State, be it Massachusetts, California, New Jersey, it's actually different. And on top of that, it's actually different